Hello, everybody. Welcome back. My name is Tom Danvers from Waygate Technologies. Welcome back to those that may have joined the last time round. This session is number 2. So we're going to be talking about depths and the various means upon which you can measure and interrogate your image and measure depths using your Borescope. So there's lots to cover in the next 30 minutes. Hopefully I will keep it to 30 minutes this time. Just a bit quick of an overview, making sure that really the whole purpose of this is to really help you extract as much valuable sort of measurement accuracy out of your image that you're capturing using your Real3D Measurement enabled Borescope. There's lots of features, visual aids that are present on the screen. Some of you may know how to use them, some may not. So really the aim is to really help you through understanding what's involved in making that happen. And we obviously appreciate that it's very necessary to make sure that you're generating the most accurate measurement out of the image that you're acquiring so that you're making the right decision based on your inspection. So today, we'll be focusing on depths. The last session was on length, so this is all about depths, and really, again, touching on the 3D surface masks as well that you presented to you in the various depth types that we have present on our Borescopes. A short sort of overview, as I have done in the past, and as I will do in the future. A quick overview of all of the different sort of measurement technologies that we have on our Borescopes. The MVIQ and the Mentor Flex Borescopes that we have for Waygate Technologies. So there's all these different types of measurement, and really I'm focusing on the Real3D Measurement enabled measurement types. So there's a lot of measurement types that you see there. Yes, I spoke to lengths quite a lot, or focused on that on session number 1. This one is really all about the depths. So those are the buttons that you have on your Borescopes with regard to measuring depths on your Borescope using either 3D stereo or 3D phase measurement. So a number of slides I'm going to take you through, and as I have done before, if you weren't on the session before, I'll be taking you through these slides as sort of example slides and going in depth as to into depth, no pun intended, into what all the different measurement types are associated with depth, before then transferring to my Borescope and kind of demonstrating to you on the Borescope. So I'll be going through that same format again today before summarizing. So the obvious one is the depth measurement. So really, ultimately, I kind of summarize this into sort of a point to surface type measurement, just like we have point to line for the length measurement. The key difference here is assigning a measurement. Sorry, I was going to say measurement plane, but that's a mistake. A reference plane associated with 3 points to basically draw and assign a reference plane before dropping a 4th point, which measures a perpendicular length from that plane. So what you see on the screen here is an interesting image that I captured from an engine fairly recently. These variable stator vanes that were rubbing on the inner platform, probably because the bushes are wearing out, I'm guessing. And I chose to drop a depth measurement into there just to understand the depth of wear into the inner platform surface that you see there. So there's 3 points assigned around on top of where I think is the 4th point. And you can see a 3D surface mask, a green 3D surface mask that represents the points or the surface points that are in agreement with the measurement plane, with the reference plane. Forgive me, I keep talking about measurement plane. The reference plane is essentially a plane that has kind of a 0 thickness. And the points that agree with that reference plane, plus or minus a very short amount, or approximately 1% plus or minus of that 0 thickness line assigned by the 3 points, are illustrated to you using that green mask. So it's good agreement. So we're looking for good agreement when you're assigning a reference plane when working through a depth measurement. And the fourth point is dropped into, if I have my mouse hovering over it, fourth drop point is dropped into the area that you want to measure the depth from that reference plane. And you can see a splodge of blue. Basically, that represents a gradient, a range of colors. If this was a much deeper depression from the reference plane, you'd see a series of colors. And I'll show this on the Borescope when we move across. And that really helps you understand the contours, the sort of three-dimensional contours associated with the various depths projected from that reference plane. So yeah, we use depth a lot. You can use the depth a lot, especially when you're obviously on flat plane surfaces and you're projecting a distance from that. So here's obviously a depth associated with a depression, and I'll go through another example on the Borescope shortly. The next one is depth profile. So I'm going to be talking to you about masks and 3D masks quite a lot as we go through this session. You can see a range of colors. So here with depth profile, there's 2 points that you assign, and what those 2 points are meant to basically be assigned to a surface that is in complete agreement with each other. So here's an example where you can see the 2 points either side of this depression that you see on the surface that are not in agreement with each other. And you can see the green mask that isn't illuminated across 2 of the points either side of this depression. So I've kind of on purpose assigned my cursors in an incorrect position, and hence why I put a red cross against it. And intentionally also aligned my 2 points so that it doesn't coincide with the deepest part of this depression, and hence showing you the range of colors as they deepen from blue to yellow to orange and red. The depression is growing in depth away from the reference plane, either the 2 cursors either side. So depth profile is a simple sort of line drawn between 2 cursors. You cannot control where the 3rd point drops to, because it's always going to present to you the deepest point between those 2 cursors. And it not just measures the depth at that point, but also the range of depths from both of those 2 sort of datum positions that you assign on the screen. So it's a very useful means upon which to pictorially illustrate the gradient of depths between 2 points that should be placed in agreement with each other. So they're very, very useful to measure and understand the shape and depth of a pit, for instance, or depression, or wear or grooves. But yes, important to make sure that you're assigning your cursors accurately and in agreement with each other, and hence in agreement with the green surface mask that you'll hear me repeatedly talk about. So depth profile, that's a very unique, well, it is a unique measurement associated with real 3D measurement types. As opposed to depth, we have depth on basic stereo or traditional stereo as well. But this is depth profile associated with 3 points, 2 points, and you see the 3rd point associated with a maximum depression below that plane. There is a button on the Borescope that you can toggle, and basically it will detect the maximum sort of protrusion or projection above that plane as well, if you're looking to perhaps measure the highest point across a weld bead, for instance, as opposed to a depression. And this is an image associated with an area depth profile. So unlike depth profile, which is essentially a sort of a 2-dimensional slice between 2 cursors assigned to the screen, area depth profile is the assignment of 3 cursors, and you're basically selecting an area upon which the algorithms are detecting and performing measurements against all of the slices across the area that's selected on the image. So what you have on screen here is a very shallow, or is a depression on the leading edge of an aerofoil. And I've assigned 2 cursors above and 1 cursor below that aerofoil. And you might appreciate this is a curved surface because it's a leading edge of an aerofoil. And so rather than it be a flat surface, area depth profile allows you to assign essentially a reference plane across a curved surface. And then perpendicular across that curved surface, you're basically allowing or instructing the algorithm to perform a series of automated depth measurements across that area. And so automatically the instrument is presenting to you here the maximum depth across that area, in this case a depression of 0.19 millimeters, coinciding with that depression that you see. And as I was saying earlier, with the depth profile, you're able to sort of see the contours. So I've activated the split screen, showing also not just the 2D image on the right, but the sort of the profile view on the right. Did I say the 2D image on the right? 2D image is obviously on the left-hand side, and the profile image is on the right-hand side. Just like you can do for depth profile, you can get the profile view also on area depth profile. So it's a very useful means upon which to measure automated depths across an area, especially a curved area, or work on a flat area. But it's very ideal, assuming you apply the cursors correctly, which I'll obviously help you through when I go into the demonstration on the Borescope. It's a very useful means upon which to, rather than find that deepest point manually, that you allow, basically you select an area and the instrument will do that automatically for you. So very useful for foreign object damage or FOD impact damage, and used to a larger extent on the shroud liners, where you can get lots of depth or wear associated with blade rub on the abradable liner, so you can drop the cursors either side of the rub on an abradable liner, for instance, and use the instrument to detect itself, rather than having to do it manually, what that maximum depression is, for instance, on the shroud liner. And the fourth type of depth measurement, so there's four on our Borescopes, on the Real3D enabled Borescopes, is blade tip clearance. So similar to depth profile and area depth profile, this is another automated measurement type. This one specifically uses feature recognition to detect a shroud liner and a perpendicular blade surface, upon which obviously there is a tip next to that. So it will detect the tip and the shroud liner, or the abradable liner, I keep calling it, and automatically perform a series of depth measurements between the tip and the shroud liner. So hence why I was saying it's an automated way. You don't actually place any cursors onto the screen. You tap the button, and assuming it recognizes those features that I just mentioned, all of those cursors automatically appear. Most of those cursors can be manually interacted with. Some of them can't, but I'll explain which ones can and can't when we move on to the Borescope. Essentially, what you see here is a reference plane, signified by the three cursors on the right-hand side, sort of are placed automatically on a surface that is in good agreement with each other, and hence flooded with the green surface mask. And you can see, as you look further rearwards across the abradable liner, that there is a series of wear marks and depth and grooves associated with the shroud liner. And then before it sort of goes back into agreement, and you can see towards the trailing edge, more green. So basically more surface points that are in agreement with the reference plane, indicated by the three cursors on the right-hand side. And what you see here is detecting the edge of the blade, and that's corresponded by the white line that you see along here. So that's the tip of the blade. And there's a cursor associated with the leading edge and the trailing edge. Those are cursors that you can also move if you so choose to. And the ones that are automated are these other two cursors with a larger circle and a small circle. The large circle corresponds to the maximum depth, in this case, just over 1 millimeter, and the minimum being 0.4 millimeters. So as you can, if you so choose to, with the toggles with the cursors on the leading edge and the trailing edge of this blade, you can move your cursors so that it's detecting maximums and minimums at a different area within your blade. It's worth noting here that you can see on a lot of these measurement types, you can see the serial number of the tip, but more importantly is the type of tip used in this case. So blade tip clearance is a classic application where you're really wanting to gather a lot of real 3D measurement information. In this case, this is a 3D phase measurement image because it doesn't have the plus next to the serial number, so I know this is a 3D PM image. And the green tip is a super long range tip, so it's really suited to gathering a lot of real 3D measurement information, and hence why it's able to really achieve a lot of distinguishing sort of measurements associated with the leading edge and the trailing edge of this blade. So that's blade. We've gone through depth profile, area depth profile, and blade tip clearance. So 4 different types. So as I've done so in the past, just bear with me a few seconds. I'll switch over to my Borescope and we'll move on to the practical demo. So let's press a few buttons. Share. Stop that. Share that. Okay. Right. Should see my Borescope now. So got a range of images here. So I was going to go through those 4 different depth measurement types using my Borescope with a range of sort of images that I have loaded on here. So you might notice, you might realize here we've got essentially a seal segment. So it's a little bit like an abradable liner in the compressor. This is a seal segment in a turbine stage. That's indicated by the honeycomb structure that you see in the center of the screen. And the blade is, or the blade tip, or the blade shroud is located at the bottom of the screen. So let's get the right button. Go into measurement. So let's move into depth. So you might recall, set up a reference plane. So I'm going to drop in a reference plane, and it's immediately, so if I activate one of those cursors, you can see a lot of green agreement with my reference plane, which is exactly what I'm looking for. If I adjust one of those cursors and move it well off that abradable liner, that honeycomb liner plane, I'm shifting clearly one of those points significantly off that plane, and so you see the green mask significantly change. So we're looking for really good agreement. So just to remind you, plus or minus 1% of that reference plane, those surface points that are in agreement with plus or minus 1% are filled with green, which is good. So you need as much green as possible to have good certainty. And because it's solid green as opposed to like a speckled or intermittent green, that would indicate that we've got a very flat surface. It's in very good agreement. And also it's indicative of a low noise. So it's a good quality 3D point cloud. You might be able to tell the serial number has a little plus next to it on the top right hand side. So this happens to not be a real 3D phase measurement image. This is a 3D stereo image, but they're both real 3D. So basically we can still interact with the point cloud, even though we've got a stereo tip fitted. So I'm just selecting and interacting with the point cloud on the right hand side. It's worth obviously noting also, when I assign my 3 points, the 4th point was assigned to me automatically. And so what's happening here is we have this feature called Depth Assist. Depth Assist enables you to rely on the instrument to present on the screen the point immediately perpendicular to the reference plane assigned. Sometimes that works and functions. Sometimes it doesn't. It depends on the position of the 3 cursors associated with your reference plane before it decides whether to drop the 4th point automatically. But you can move the points around. They're all editable. Let's move that measurement box to one side. You can, and just as a reminder, if you didn't already know, the red coincides with no 3D data associated with those areas. So you cannot place your cursors onto points or into areas where there is no 3D data. So you can see that I've kind of adjusted some of the cursors. If I press and hold it down, it'll snap back to the depth assist location, which is the depth associated with the maximum depth from that reference plane. So it's kind of just showing you that as opposed to the variable stator vane depth one, because this is a classic sort of tip clearance, a manual tip clearance rather than an automated tip clearance way of using depth. Let's see what I've got up next. Okay, so there's my VSV, variable stator vane. Let's drop a depth into here like I was showing on the PowerPoint earlier. Right, let's, again, you can just see, if I just go back, where is it? There's all the red again. So that's just to remind you, that's where there is no, in this case, 3D phase measurement data. There is no plus next to my probe tip serial number. So I know this is a 3D phase measurement image. So I've assigned my 3 cursors. You'll notice I haven't got a 4th point automatically assigned to me. I'm just going to adjust my point cloud. So now, if I press enter or just tap the screen again, it'll drop my 4th point onto the image. I could be doing this on the point cloud on the right-hand side of the image, or I'm interacting with the left side at the moment. So you can see, as I move my cursor, you've got that really useful color gradient. And you can see, if I just zoom in, let's interact with the cursor on the right-hand side. There we go, come on. Oh, it's not interacting. Let's go back to the left. Okay. So you can see as I'm moving my cursor towards the dark red zone, my depth measurement of 0.46 millimeters is going to grow in size as I move towards the red sort of area. As I drop my point, you can see it's grown to sort of 0.51 millimeters. So it's a very useful way of helping you drop the point where it coincides with the maximum depth from the reference plane, indicated by the 3 cursor points. So that's using exactly the same function, depth, in order to measure essentially the length from a reference plane. Right, if I scroll to the right, here we go. So we got a different image here. So actually, this must be a customer. This is not one of the images I've captured in the past. So this must be generated from another application, maybe from a customer. So this is the inner bore of a tube. Now, I wanted to show you basically depth profile and area depth profile in this application. You might remember it's basically essentially assigning, once you've assigned 2 cursors and they're in a good agreement with each other, I've not pressed any button, and you get that 3rd point sort of automatically presented to you. Again, let's use the point cloud and understand what it is we're looking at in a little bit more detail. So we know our 2 cursors that I've assigned with the 2 blue circles next to them. They're in good agreement because we've got the green surface mask flooding all of that area. So with depth profile, it's just illustrating the topography or the gradient or the profile between those 2 points. So I can go to views and show you the profile view. And if I wanted to, I can actually adjust the, I didn't need to do that. Let's go back to profile view. I can actually adjust the point. Well, it keeps snapping back. So you can adjust the point. There we go. Oh, that's a little bit of a weird thing happening. Okay, let's not press any more buttons. So there's my 2D image on the left and my profile view on the right, just showing you not just the maximum point below the plane or below my 2 cursor points, but but also the shape of that groove. But the disadvantage of using depth profile is that you're basically only going to get a measurement associated with the 2 points that you assign. So you have to sort of adjust your points and make sure that you're sort of coinciding with the depth or the protrusion above the plane between those 2 points that you've assigned. So if I was to just delete this and move to area depth profile using this same image, so I just press area depth profile. So this exact why I'm really using this image is because you'll see there's a weld bead, but also an undercut area where there is no weld. So what I've done is assigned 2 points to one side of the weld bead, these two here, and my third point is perpendicular to that. So you can see the sort of the 2 white lines that coincide with the area that I've essentially selected. And what's happened here, it's automatically scanned all of those lines projected perpendicular from my first 2 points all the way across the image, and it's presenting to you the maximum depth below that reference plane that's shown to you in a green surface mask. If I was to go to page 2 on the soft keys and press above plane, so it's, again, done exactly the same. It's scanned all of those lines within that selected area, but presenting to you the maximum point across that area that's selected. And yes, just like I did before, you've got the profile view available to you, both in maximum and minimum. An interesting little feature that we have for area depth profile, you may have seen it here when I went into options. If you were to press sweep profile, it's basically presenting to you the profile between all of those in that selected area, whether it's the deepest or the maximum. So it's selected for maximum at the moment. So it's always going to show you the maximum. So that green dot on the left-hand side, or the blue point in the center on the right-hand side, is showing you the maximum. And then it'll snap back. After the end of the profile, it'll snap back to the maximum, which is 1.25 millimeters. So still talking about area depth profile. So you heard me talk earlier in the introduction, really associated with a depression on the edge of a blade. And really, it's something that we find sometimes can get misinterpreted. It's very important to make sure that you're assigning your cursors correctly when using area depth profile. So I'm going to select it again here. So just like you saw me do on the previous image, where I set my 2 points across a curved surface, and my third point was essentially along the same plane, so to project from that curved surface. I'm going to do the same here. So my curved surface is here. I'll drop it onto the, let's say, the leading edge of this aerofoil, and my second point, let's say, off to the background slightly, and my third point is going to be projected away from that, so that you can see my green mask again. So I just press enter. Let's move that out of the way. So it's the flat surface essentially doesn't exist here. So we've got the reference plane. Unlike the depth measurement, the reference plane can be flat or curved when it comes to area depth profile. So we've got really good agreement of my reference plane, because you can see everywhere included in my area is flooded in green surface mask, which is telling me that's great. And just like you saw in my previous image with the weld image, it's presenting to me the maximum, in this case, depth below that reference plane. So you can just see it here. The pink line is the point upon which it's measuring that length below the reference plane. So in this case, 0.21 millimeters. Go to page 2. Well, I've got to have the left-hand image selected. Go to page 2, and you can see my sweep profile. And you can see the depth associated. Every time it runs a scan, it's giving you an updated depth on the left-hand side. So essentially the value is very, very low, or 0.05. So there will be noise in that signal. So essentially it will be close to zero, plus or minus a small amount. But this, you can see with confidence that it's detected the depression. We have a good MTD, the maximum target distance, the value that you see on the top left-hand side. That's telling me that out of the 3 points that I've assigned to this image, one of them is 6.38 millimeters, one of them being the maximum value of 6.38 millimeters. So because I'm using the black tip, you can see on the top right-hand side, I know I'm very close, and I'm well within the limits of the capability of the black forward-facing 3D PM tip. So there'll be another session that I talk about with regard to tips and which ones to use in which applications. So having an understanding of which tips, in this case, which real 3D measurement tips, whether they're stereo tips or 3D phase measurement tips, making sure you have the right one fitted so that when you're acquiring a measurement image, you've got a good low signal to noise ratio. And therefore you've got to increase your chance of having a good measurement. So let's come away from that. So we've talked about depth profile, and area depth profile. This is the last one, blade tip clearance. So a braidable liner on the top, the blade, a compressor blade on the bottom. So I'm just going to press measurement and press blade tip clearance. You heard me say this is an automatic measurement type. So it's assigned all those cursors for you automatically. Again, just like any other real 3D measurement, you can interact with the point cloud. Make sure you're happy with your cursors. You can see there's a maximum, a minimum, and average. And if I sort of move my, let's say that's the leading edge, which I think it is, it's moving my maximum value. Where's my maximum? Yeah, there it is. Yeah, there it is. So my maximum value is moving as I move my my limits of leading and trailing edge. And if I wanted to, I could adjust my reference plane if I wanted to, but don't want to move. I want to have much better agreement. You can see there's sort of some islands of green, of missing green in that area. So there is area where there is perhaps more rub, and it's exceeding that 1% threshold that you heard me talk about earlier. So just a quick sort of demonstration of in this case blade tip clearance using the yellow tip. You can see YEL on the top right hand side. So that's our new forward-facing high range 3D phase measurement tip. So this was a useful tip for me to acquire this image using a forward-facing 3D phase measurement tip that has a longer or a greater range to acquire more depth within the scene for 3D phase measurement, as opposed to this other image that I captured using the red tip. So another new tip. This is our close focus side-facing 3D phase measurement tip. And you might recognize that's a leading edge of a HB turbine blade with some thermal barrier coating missing on the tip. On the left is essentially the seal segment surface. On the right is the blade. So if I just press measurement and blade tip clearance again, it's done all that automatically for you. Reference plane assigned, good agreement. You can see my maximum and minimum values associated with the cursors, with the big blue blob or circle, and the little one coinciding with the minimum value. If you can just make out, there is a faint blue line that coincides with the maximum value of 2.15 projected across the tip of the blade. I haven't mentioned that before, but that blue line basically is a good indication of showing you, well, that's kind of the difference between the minimum and the maximum as you move across the surface of the blade. So I know I've gone over a few minutes. Let's just go back to my slide deck. Let's go back here. So a quick whirlwind overview of the various depth measurements that we have on our Real3D Measurement enabled borescopes. Was it not working? Not sure if you can see my screen. Let's try that again. Window. Share. So hopefully you can still see my my slide, my summary slide. So we've talked about the depth profile, area depth profile, and blade tip clearance. And the importance of making sure that your measurement image, just like doing any measurement type, not just depth measurements, but it is very important with depth measurements more so, to get nice and close and maximize your chance of having a very low signal noise, very low noise on your measurement image, such that when you're assigning your cursors, they're going to be coinciding in good agreement and giving you a good quality measurement output. We have a range of these masks, the green, the blue, and the color gradient. Depending on what measurement type you're in, you might not get the color gradient, for instance, but pay close attention to your green surface mask. They appear on all of your depth measurement types. They ensure that you've got good agreement with your cursor positions, and you should get a good measurement type, measurement output as a result of having those masks in a good agreement. Quick mention again about the measurement handbook. I mention this all the time when I can. It's a very comprehensive document. There's a link, a little bit of a shorter link that I provided this time for session 1. It's a much better quality link. So clicking onto that link or typing into that link into your browser and going down to the resources section and sort of selecting for handbook, you'll be able to download that. It's a very comprehensive document that gives you a lot of detail. I know this is just a quick 30-minute overview. It's a lot of detail of all the measurement types, obviously including the depths. And before finishing, it's worth just highlighting there is a promotion associated with the Everest Mentor Flex borescope, not the MVIQ, it's the Mentor Flex. We recently introduced the ability to use Real3D measurement for 3D stereo only on the Mentor Flex earlier this year. And there is a 50% promotion for those customers that are existing stereo measurement enabled Mentor Flexes until the end of this year or the beginning of next year, where you'll be able to upgrade at a heavy discount, 50% discount if you were to go to an upgrade to 3D stereo. So it's a very useful tool, fundamentally enabling you to really interact with your cursors and understand your surface a lot more by using the point cloud as opposed to using the traditional stereo method. So sorry again for going over the time. It seems to be a common theme for me, but I like talking about measurement and all things borescope. Thank you again for joining, and I'll see you next time. Goodbye.